Hello, everyone. So today I'm going to continue with the previous concept, which is called as metallic bond. I taught you last time the ionic bond. Ideally, I should probably teach you covalent, but I have decided let's move to the metallic bond because it's very interesting. It is not like covalent or ionic, yet it is a bond. Uh, Mostly the question comes that what type of bond it is. Is it between metal and metal? No, a lot of my students, they go wrong in answering this question, and I always ask as a fun question because they do think that probably two metals they bond with this, but that's not true. It is actually the force of attraction between the nucleus of an atom and its outermost electron. So how does that work? And the different metallic properties like conductivity and the malleability and ductility, everything, it depends on the metallic bond. So I'm going to share my screen. I'll show you a picture and I will explain you more. So here we go. This is our, this structure. What you see is a structure of metallic lattice. Now, what is a lattice? Lattice is a regular structure. Okay, so what we see is metallic lattice. And what is lattice? Lattice is a regular structure, any kind of where some kind of organization. So as you can see here, right, that there is an order, there is kind of arrangement between the protons, between the cations and the electrons. So that's why it's called as lattice. So this is metallic lattice, and we see a fixed arrangement of cation. Now you can ask me how come it became cation. When it became cation, the very interesting thing about metals is that when they are in a lattice, okay, the organized structure I was talking about. So the cation and the outermost electron. I think I should explain you that. So and outermost electron. So here I was talking about this diagram, what you're looking at. Let's say sodium. Sodium is my favorite element because it reacts very well. The configuration is easy. All of my students, they know this. So this is 281. This is electron configuration. Now this 1 is the outermost electron. All right, so this is outermost electron, and this is very strongly pulled towards the nucleus because nucleus is basically the proton, right? Of course, you understand that. So there is a very strong force of, bond, that is electrostatic force of attraction, and because of that, these electrons, even though they are outside of the shell, still it is not attracting it is not going away. It is still held by the strong force of attraction from the nucleus to the outermost electron. There is a strong force of attraction. Okay, that is what you have to remember. Now the next thing is that how does that help? So this is between only one type of metal, not different type of metals. What does it mean? Like the picture what you are looking at is just about sodium atom and its outermost electron. So that's what you are looking at, just one type of electron and one type of cation, because they are moving in the lattice constantly. Because the electrons are moving constantly, guess what will happen? It will help in the conduction of heat. And it is not just heat, it is always heat and electricity. So this is what is going to happen. There will be conduction of heat and electricity throughout. Okay. So also when you hammer, when you hammer a metal, what do you observe? You observe that sheets are being formed, right? Which is basically, in one word, we call it as malleability. So malleability is also because of the layer of these atoms here, the cations. So it is not that, in the lattice, the metal atoms, they are not existing. It is still neutral. They are not really cations, but when we observe them closely, it is the cation and the outermost electron. So malleability is can be explained by metallic bond. So if we are able to explain a malleability, can we explain ductility? Yes, we can. Ductility too. And what is ductility? Ductility is ability to pull the wire in the metal. In non-metals, they don't have this property. Only metals they have this property. Okay. So malleability, ductility, conductivity, all these properties can be easily explained by what in the diagram you are looking at as metallic bond. You can have an instant question that does this kind of bond exist in non-metals? Non-metals, they don't have something like non-metallic bond. That does not exist. They have intermolecular force, what we call it as intermolecular force, and that exists in different ways, which can be completely another topic. So for that, I think I would like to, do another video for that. But for now, we just understood metallic bond. One more time, the important points would be that it only exists between one type of metal and its lattice. It's basically the force of its attraction, the strong force of attraction between the outermost electron and the nucleus. Even though the electrons are moving in the lattice, still they are held by the nucleus and its force of attraction. And this property of constant moving of the electron explains a lot of characteristic of the metallic bond and the metals. I hope you have understood what I'm trying to explain about the metallic bond, and I'll see you soon with another video with covalent bond. Thank you so much for watching. Keep watching, subscribe my channel. Thank you.